Hey guys, how's it going? Today, for day 22, we're going to take a look a little bit at the second derivative. The second derivative has some very, very important properties that we're going to learn later on. But first, I just want to talk about calculating the second derivative, how we do that, both explicitly and implicitly. So let's talk about notation first. If we want to show the second derivative notation, here's the kind of notation that we're looking at. So it kind of makes sense. The second derivative is like f prime prime of x. So putting two of those apostrophes there show that we're talking about the second derivative of f of x. Okay. The notation with dy dx is kind of funky looking. It looks like this. So it looks like d squared y dx squared. So those are our notations that we use. Notice in the second derivative with dy dx, it's the d that has the superscript 2 in the numerator, but it's the x that has the superscript 2 in the denominator. So just notice that and be comfortable with that kind of notation, both recognizing it and using it. So let's do a couple of examples. To calculate the second derivative, if you're are given f of x, you just have to do f prime of x and then do the derivative of f prime of x. You're really just doing the derivative twice. So let's take a look at some. This can be really easy and it can be kind of challenging. I'll give you a couple of examples. Okay, so let's say we have f of x equals 8x to the fourth minus 3x cubed plus 2x plus 5. And your goal is to find f double prime of x. Well, to find f double prime of x, we first find f prime of x, and then find the derivative of f prime of x. So f prime of x here would look like this. So we'd get 32x cubed minus 9x squared plus 2. That's f prime of x. And I'm just going to do the derivative one more time to find f double prime. And 3 times 32 is 96. So we get a second derivative answer of 96x squared minus 18x. So with polynomials, this is pretty easy, okay? And really, if I ask you to find the third or the fourth or the fifth derivative, you can just keep doing this and it will come out eventually. It can also be a little bit harder too, so let's take a look at one of those. So let's say we have f of x equals e to the 5x squared plus 1, and our goal is to find f double prime of x. Okay. So again, I'm just going to do the same process. I'm going to find f prime of x, and then once I get that, I'm going to do the derivative. So f prime of x here is going to require a chain rule, because I see a function, 5x squared plus 1, within a function e to the x. So the chain rule says do the derivative of the outside with respect to the inside times by the derivative of the inside, which would be 10x. Okay, rewriting that, I'd call this 10x e to the 5x squared plus 1. So that's my first derivative. I had to use the chain rule. But to do my second derivative now, it's going to end up being a hybrid derivative. You need to recognize this as 10x times e to the 5x squared plus 1. So to do the second derivative here, I'm going to need to use a product rule. And that product rule is also going to be hybrid because I'm going to have a chain rule as part of it. So again, I'm going to think of this as my first. And this is my second. So f double prime of x will be the derivative of the first, which is 10, times the second, which is e to the 5x squared plus 1. Derivative of the first times the second, plus the first times the derivative of the second. But the derivative of the second here requires a chain rule. So its derivative is going to be e to the 5x squared plus 1 times 10x again. So simplifying down the second derivative, I'm going to get 10 e to the 5x squared plus 1 plus 100x squared e to the 5x squared plus 1. So more complex functions require more of a complex second derivative. Okay. Now I want to talk about how we do this with implicit differentiation, finding the second derivative. But there's a little caveat here that you need to pay attention to. So I'll dial up a problem here. So here's my problem. 4x squared plus 3y squared equals 12. And again, my goal is to find the second derivative. Because we're talking dy dx, it's going to be that different notation. I usually say things like find the second derivative in terms of x and y. So again, my process to find the second derivative is to first find the first derivative and then find the second derivative. So this is implicit, so I have to remember my dy dx. I'm going to go through and derive this thing. It's a relatively simple one to do the derivative of here. Let's do something like this. So again, this is relatively simple to calculate the first derivative of. Now I just need to isolate dy dx. So I'm going to subtract 8x and divide by 6y, and I'm going to get dy dx equals negative 8x over 6y. Now you're going to make your life a lot easier for yourself if you simplify right now. Okay, we can't cancel out any x's or y's, but 8 and 6 are both divisible by 2. So I'm going to write this as dy dx equals negative 4x over 3y. Okay. So that's dy dx. Okay? Now here's where we need to be careful. When we do the second derivative, right, we're just going to do another derivative right now. Okay? But again, it's still implicit, so when we do the derivative of y, we still need to multiply by dy dx. Okay? What I want you to do is once you get the first derivative, I want you to circle that answer, because it's going to come into play later. Okay? Now I'm going to go ahead and apply the second derivative, or do a derivative again. The derivative of dy dx now is going to be our second derivative notation. So doing the derivative, I end up with this. Now to do the second to do the derivative on the right side, I need to use a quotient rule. Okay? So I'm going to, and again, when I do the derivative of y, I need to multiply by dy dx. So the derivative of the top is negative 4 times the bottom, 3y, minus the top, negative 4x, times the derivative of the bottom, which is 3 dy dx. So again, derivative of the top times the bottom, minus the top times the derivative of the bottom. Notice that dy dx popping out because the derivative of 3y, I have to multiply my derivative 3 by dy dx. And I'm going to divide the whole thing by the bottom function squared. Make sure you put parentheses around that 3y to square. Okay. So what I'm going to do right now is clean this thing up a little bit. And I'm going to get this negative 12y plus 12x dy dx over 9y squared. Okay. And that is my second derivative. The problem is you were told to find the second derivative in terms of x and y. Right now, our second derivative is in terms of x and y and dy dx. So how do we get rid of that? Well, that's why I had you circle up here. We need to sub this thing out for this. Okay? That's why I want you to circle it so you remember where it is. So I'm going to plug that negative 4x over 3y. I'm going to sub that in for dy dx. And I'm going to simplify because this could be on multiple choice. So I just rewrote my second derivative there. But I replaced that dy dx with what dy dx actually is, which is negative 4x over 3y. Now, this is our answer in terms of x and y. However, it might be a good idea to work on simplifying this thing. One thing I see when I simplify this, this 12 and 3 are both divisible by 3. 12 divided by 3 is 4. So cleaning up this top, I'm going to get negative 12y. This is now going to be minus 16x squared. So I have an x times an x, a negative 4 times a 4. Over y, I still have y in my denominator, over 9y squared. Now, if we don't want to leave a fraction within a fraction, we can multiply both the top and bottom by y, and we get this. Negative 12y squared minus 16x squared over 9y cubed. And then I'm going to look at 12, 16, and 9 and see if I can simplify that. And I can't because they don't all divide by the same number. So this is my simplified second derivative implicitly. All right, that's it for today. We'll practice some of this stuff tomorrow. I'll see you guys later. 2 chains, bye.